should be good to go.
Hey friends! I am so excited that we are back for day 4 of our out of this world science projects that we're doing all week. For those families who are new, make sure you subscribe to our YouTube channel so you can see us live every day at 11:30 when we're here. And make sure that you check us out on social media and you can share all of the fun projects that we are doing. And I always like to tell you guys what you need before we get to our shout outs. If you want a shout out, if you've got a little person who's really excited to do science and they want a hello from me, type your name in the comments box and we'll give you a shout out today. And then I'll do that after we go over our materials. So in our download, it came with your email that reminded you that we're going live today, is a fun little solar sleuthing project that you can print out if you would like to. It's a couple of pages and it'll be really fun. We'll learn about how we can use this to discover what is in our sun later today. And so you need that, and then you don't actually need these. These are things that were on the supply list when we started our 6 weeks of science in the very beginning. So if you have these, today is the day to bring them out. If you don't, that's okay. We're going to attach one to the camera so you guys can see a lot of what we're doing. It's just going to be a little trickier and shufflier today so that we can see some of this fun stuff that we're going to do. And then you do need scissors to cut this stuff out. But that's really all you need today. We're going to have a fun little exploration of how we
can dive into this.
Awesome. All right. So get ready to comment because here is my question. We know what the sun is made of. We could tell you what the sun is made of, but I'm curious, how do we know this? How could we figure out what the sun is made of? So if you have an idea, type it in. And I'm curious, how could we figure that out? How can I tell you what the sun is made of? That's
you're
curious.
Assuming that they know what the sun is made of.
Well, we could look up what the sun is made of.
It's true.
You guys could get on Wikipedia and you could type in what is the sun made of, or you could open a book and read what the sun is made of. So that's how we could personally learn what the sun is made of. But I'm curious, how did that book, whoever wrote the book, know what the sun was made of?
Who's got a guess?
Who has a guess? This is my favorite part of this question because the guesses are always fantastic.
So we have one guess.
Okay.
Megan Hurt says fire and lava.
Ooh, Megan, great idea. So fire and lava kind of look like the sun. So maybe we could sample fire and lava and see. Here's the trick with that though. One, the sun doesn't burn. So that kind of kills fire because fire burns. It uses oxygen and that's actually a combustive thing. The sun doesn't. It fuses things together and that's what creates the heat. So we can't use fire to learn about it, but great idea because fire kind of looks like the sun in the sky. So if we knew what fire was made of, I see that connection. Lava, we have learned, is just really hot rock. It's a solid that we heat up really hot. And the sun is not like that. Good idea, though. That's the first time I've heard that. It was a great idea.
Kaya has put out fire and also light.
Light. Ooh, I'm curious what Kaya means about light. How could light tell us what the sun is made of?
Rachel is saying that we could use a glass triangle to find out.
A prism. Yes, we could use a glass triangle to find out. In fact, Rachel, you and Kaya are on the right track. We could use a glass prism and look at the light of the prism, and that could tell us what's in the sun, which is kind of interesting.
We have Mila who is saying we can look at our planet and look at the sun and we can compare.
Ooh, I love that idea. We could look at our planet and look at the sun and we could compare. And in fact, Mila, you have something there too. We can combine yours with Rachel and Kaya's. We could look at the sun with the prism and then look at the light on the other side of the prism. And we can look at stuff on Earth to compare the light from the prism to stuff we see on Earth. You guys are doing a really good job. You guys are getting the pieces on the table and you're putting them together. I'm super impressed right now. Super impressed.
Griffin knows the answer. He just wants to dump it out there. No Griffin.
Some of my friends do know the answer because I know Millie knows the answer too because she came to a Girl Scouts meeting with me.
So Kaya added energy to her light and fire answer.
Yes. I am so impressed, you guys.
We have
so impressed. I teach middle schoolers sometimes, and their response is always let's send a rocket to the sun and scoop up the sun and bring it back. You guys are doing a really good job. You're thinking really critically about this because energy is really, really important to knowing what our sun is made of.
So Leonard and Barbara are saying maybe something from the sun fell down on Earth.
That would be cool. Not that I know
photons.
of. We do get actually like solar flares that sort of burst out and like the sun burps and it has like all this stuff. I know. And you can actually look at like videos of the sun of this happening. It really looks like it's like this ball and it's like and it comes towards Earth. And in fact, those things are kind of what makes the aurora borealis. If you've ever heard of those, it's like these beautiful sort of like skylights, but they're all like green and blue and they sort of like wave in the sky like this. They're beautiful. And that's from sun burps. But that doesn't necessarily tell us what the sun is made of.
We have the Connor and Grayson are saying gases.
They brought like the last piece to the table.
Uh-oh.
You guys have done it.
We have light, heat,
You guys have
energy,
done
and
it. So,
gases.
we have gases. And gases have certain energies. They can only jump to certain spots for gases. And the more spots you have, the more energies they can have. So really simple things like hydrogen is just a proton and electron going around. And that hydrogen could eat up some energy and the electron could bump up in energy level. And it could eat some more energy and it could bump up again. And so when that hydrogen who's really excited, we call that being really excited, super happy, yay, it's a party. It's like way out here, it's super happy. But all parties have to come to an end. And so it sort of burps out light as it comes down. And how much energy it stepped up chooses the color of light that it burps out, which is really cool because they can go from hydrogen to like helium, and helium has extra stuff. So it has 2 electrons, and it's got 2 protons, 2 neutrons, I think. And it has more things, right? You could have like 1 electron jump, but not the other. You could have both electrons jump. You have all these other options of what you could do. And so they could burp out all different colors of light. They could burp out more colors of light than hydrogen. And you can imagine as you go up that periodic table, the amount of colors of light you could burp out as you're really excited and having this great grand party. And you're like, oh, party's over. And you burp out all of your light to come back to your normal state. You burp out more and more different colors of light. So that's really useful. Gases and energy, super useful. So we're gonna take that and we're gonna blend it with our other puzzle pieces. So we have our gases that are burping out different colors of light. Every gas is unique. Like, it's basically the way it burps is like its fingerprint.
So I think we need to take that slower.
Okay.
And see if we can break it down
More.
slower and more.
All right. So we've got gases. And those gases, like, you know when you heat up, let's see. Well, what could be reversible? Well, you know when you heat up ice, it sort of melts, right? We put energy in and it melts, but we could freeze it again. We could take energy out and we could freeze it again. We could do the same thing with like all types of gases. The air around us we could do it with hydrogen, we could do it with neon, which is what makes neon signs, and we could either heat it up and make it really excited, or we could cool it down and make it normal. And what's nice is that when you heat it up, it sort of eats up, you can imagine the way we heat it up is like it's eating all different colors of light. But gases are really picky. So like maybe one gas loves to eat strawberries, refuses blueberries. But maybe another gas is like, I'm not so picky. I like strawberries and blueberries and mango and bananas. I'll eat them all. So what they eat is kind of like the energies they decide to take in. And then they can burp those out. And when we burp them out, okay, that does sound disgusting because now we're like, our little gases are burping out eating strawberries.
We have a solid gas commentary going on.
Yes. But we could look at the burp and we could be like, oh, that's strawberries, or that one had strawberries, blueberries, and bananas. And then we could say, this one had everything, the whole fruit cocktail.
So you can tell which gas is up there by what it burps out.
Yes.
By smelling its burp.
So we can look at what did it burp out? Because every gas eats a very specific diet. Very specific. As specific as my fingerprint and Evan's fingerprint and your fingerprint. Very, very, very specific diet. So we can look at what it burps out. And we can do that on Earth. So we could take a gas on Earth and we could give it a bunch of energy, and we're gonna do that today actually, could give it a bunch of energy, and then we could watch what does it burp out. And that's kind of cool. And we could record what it burps out, and then we would know what that gas eats. Very handy. And we can do that with every single gas that we know of on Earth. And that's how we can compare the Earth to the sun, because we could look at what does the sun burp out. But here's a trick with that. The sun has lots of gases that are all burping. It's like a burping symphony in the sun. So there's so much stuff. I mean, some of these guys both eat strawberries, and some of them eat bananas, and there's like everything is coming out of the sun. So we have like this huge smorgasbord of stuff coming out of the sun. And then the question is like, ooh, well, how do we pick out which ones are which? Which is very tricky, but we can do it because we can look at like, what brand of strawberry do they eat? And we can like siphon off the different brands of strawberry. And here it's actually the slightly different colors of light, because every fruit that we're eating is sort of corresponding to a specific color of light. We can use those colors of light to see. In fact, you see what the sun is made of all the time. You guys have definitely seen this science in action. It happens a lot in Seattle because it happens to rain a lot in Seattle. And it's a rainbow. A rainbow is showing us literally everything the sun is burping out. That is like the real world example of there's the sun's burp, and we can see all of these colors. We see red, orange, yellow, green, blue, purple. Interestingly, there are some gaps in our rainbow, but we don't see those gaps in our rainbow because they just sort of blend together. But there are things that we might think to our eye is actually being burped out by the sun, and maybe it's like a specific green, and it might not be. There are little teeny tiny gaps in there. But that is how we see what the sun is made of. And that's the same way using a rainbow is the same idea as taking light from the sun, putting it through a prism, and making it a rainbow, and then looking at it. Now,
Lila is asking, what energy does oxygen eat?
Ooh, I don't know off the top of my head, but I do have a picture of it. These are actually the food groups that every gas eats. I've done it for a bunch of different gases because there's 9 on this page and I have 9 on the other page. So this is oxygen right here. So these are the foods that oxygen eats. So it eats a lot of different red fruits, strawberries, cherry tomatoes, because cherry tomatoes are basically like a dessert fruit. Are tomatoes fruits? I'm not sure. Maybe some red peppers. We're gonna have to go fruits and vegetables here. And maybe it has some oranges and tangerines, which are slightly different than oranges. And it's got like broccoli and apples and kale. And then it's got some blueberries and maybe eggplant. Those are literally the only 2 things I can think of that are blue.
So we're assigning fruits and veggies to those colors.
Yes. So you can see that oxygen actually does a pretty good job. It has a nice healthy diet. Some of them have a healthier diet. Iron over here. Wow, look at all that. It eats a lot of stuff, not a very picky eater. You can kind of see how some of these could help build up a rainbow. Because if I took this and I laid it on top of here, I would get all of these guys, fruits that it eats, plus all of these. And if I added calcium in there, I could add those. I could add neon. Neon has like a lot of pretty reds and oranges, which we're kind of missing over here, so I could add that in. And you can see as I start to overlay everything, I'm starting to add in a whole bunch of different colors, and I'm actually starting to get what we see as a rainbow. But that rainbow actually breaks down to looking exactly like this. All of these very specific colors of food that our little elements are eating up and then burping out. So this is exactly how we do it. We take that rainbow, so we take the sun, we take the light from it, we split it into this beautiful rainbow, and then we compare it to what we see on Earth. So you guys really did a good job hitting that on the head. Now, you might be like, all right, but I don't see these lines on Earth. Like I see a nice smeared out beautiful rainbow, and you'd be right. We actually have to use some special scientific equipment to be able to do that. And we have to use a piece of equipment that can like chop up all of the foods or all of the different colors of light and then spit it out in like very specific lines. We need to be able to take all the excess out. And interestingly, you can get these online for really cheap. This is called a diffraction grating. It's like our little chop suey chopper. And if we look through it, so if you have one of these at home, you can look through it at any light, and you'll actually see the different colors that the light is made of. Now, Evan is we're gonna try to put it in front of you, and I'll put my phone camera light on. And he's looking at the camera. It's gonna take a moment. We have to figure out which way we go. But you should be able to see my white phone camera and then a bunch of like a rainbow that sort of goes to the side. He's working on it. Do I need to move my phone maybe?
That's good. It's just,
okay.
You do need to move your phone.
Which way? This way?
More. Do you guys see that spectrum of light?
So do you guys see sort of like it should look like a smeared out rainbow. And you might be like, Dr. Erica, this is just like a prism. I know, it's not super exciting yet. We're gonna get there, don't worry.
There's rainbows going on.
There's rainbows going on, perfect. Now, if I were to take something that was more of a singular color, then I would just see the single color. I wouldn't see a rainbow. We're seeing a rainbow because this is white light, and white light is pretty much all of the other colors combined. What we could do is we could try to take an LED, and this one is technically yellow, but actually if you look at it with this stuff, and I think I might give this to Evan, you won't see just a yellow line. Like you might imagine, oh, this guy, just a yellow line, but there's actually yellows, and I think when I looked at it, there was greens and reds. Although it's tricky right now because we are in a very light area. We won't be able to see this yet. And that's part of that reason is because it's so light all around us right now. We're getting so much light that we can't really see just that little guy. It makes it a little trickier.
Yeah.
But what we could do is we could go in the dark, and that's actually what we're gonna do. But before I do that, I wanna say, you might be saying, everything we've seen is a rainbow. I wonder if do I look like I have a rainbow halo? Because we still have it on.
There's quite a bit of halo going on.
Yes! Rainbow! So everything so far is a rainbow. The sun shoots out a rainbow. It burps up a rainbow because there's all of these different things in the sun that are all burping things up. And we have to be able to pick those apart. And somebody mentioned, look at it on Earth. And we can do that. We can take a gas, we can shove it in a tube, and then we can make it really, really excited. So that it gobbles up all this stuff and then starts burping all over the place. Awesome. This is how we do it. What we're about to do, we're actually gonna take you guys on a little mini rotational tour into our house, because we have this little hallway that we can close all the doors so it'll be really, really dark in there. And I'm gonna take a tube of gas, and I'm basically gonna plug the tube of gas into the outlet. So I have this awesome little machine piece, well it's not a machine, it's like a piece of equipment that you plug into the wall, and literally all it does is it like splits the two wires from the wall up to here. So we're gonna put 240 volts across our gas, which is gonna be very exciting. And then you guys can look at what does this gas burp out. And you can see the very specific lines of what our sun is made of. And in fact, if you have these sheets together, I'm gonna show you a few, and your goal is gonna be to determine which one that I show you is the hydrogen. I'm pretty sure I have hydrogen. It might be helium. Oop, that one's not helium. This one's helium. So we're gonna see if we can find one that matches up to here. And now hydrogen only has 4 lines. So we're gonna look for something with 4 lines. And so anything that has a lot of lines is not what we're looking for. We're gonna look for something with 4 lines. You guys are gonna see if you can figure out which sample I show you has that. All right? So we're gonna smoosh ourselves around so that we can go check out that. So, let's see. Here we are. So this is my gas that's in a tube. This tube is filled with nitrogen, but I have tubes that are filled with other things. And what's gonna happen is you can actually maybe see a little bit of the darkening up here. There's like a little electrode up here, an electrode down there.
Let me take this off for a second.
Yeah, and what we're gonna do is we're gonna plop it in here, and this is the little piece of equipment that when I plug it in, will have basically an open current from top to bottom. And what that does is it excites the gas so much that the gas is going to glow just like lightning. All right, so I'm gonna plop this one in. So we know this one is not hydrogen, but your goal is to find the one that you think will be hydrogen.
All right, so
we're gonna plug this guy in.
Put the diffraction gradient on, and we're gonna see which one.
Yes, we'll have to turn off all of our lights to see it.
We'll get that in a second.
Yeah. And let's see, these guys I don't think have a switch. I think it's just on and off.
So one light off.
All right, here we go.
One light off.
So there it is glowing. And we can put the diffraction grating on it. We should be able to see the lines.
Okay.
Evan is going to be our camera guy right now.
Let's see lines.
You see that part? You have to look to the sides maybe.
Okay.
That's Georgia. So sometimes the lines are off over here.
I'm looking.
We're looking for the lines.
Does anybody see lines?
Maybe that one's not strong enough. So, I know it is purple, Naomi. It's so pretty. All right, let's see. Let me see if I can see the lines with my eyeball. Oh yeah, no, this one's not very strong. We're gonna turn this one off and we'll do another one.
All right. Sorry, guys.
We'll see. Hopefully, we're able to get it dark enough. Normally, I turn everything off.
All right, I can turn
Although I would love a light as I'm changing these. Let's see which one we have. Let's put in a different one. I'm wearing gloves because I don't want the oils of my hand to get on the glass. Because there's so much energy that's going through here that the oil will concentrate the heat and then break it. All right, let's see if we can get this one. We'll see if you guys can guess what it is. It's going to be a different color. There we go. Make sure everybody's out of the way. And then we'll try to turn it on. Oh, why isn't that turning on? There we go.
There we go.
This one's a lot stronger, so this one should work.
I see. Is it diffraction now?
Is it what?
I see the reflection around.
See a reflection. Maybe go to the side. We're working on seeing the lines. No? Here, let me see there.
I saw it at the stove.
Can I see the diffraction grating real fast? Sorry guys, we are... thought that was going to work for us. Oh yeah, you gotta look... Okay. So, it's like way over... So I'm looking here, and it's way over here that our lines are.
So you're looking way to the side?
Yeah. So the camera needs to go to the side. Can we make it work in our tiny hallway?
Oh, guys, we've got lines. Who can figure out what this is?
All right. So do you see how those lines are very, very clear? There's very sharp lines. We could count the lines, and that can help us figure out what element we are looking at. So I see 3 lines, although I see one of the lines that's maybe a little bit thicker. And sometimes some of these lines we can't quite see in this situation. But you guys can look, and if you have that printout, you can look and say, what has sort of a purplish line, a bright blue line, a red line? We're definitely missing a line that we're not seeing. There is one missing line here. All right. And I want to show you guys a different one too. So look at your sheets and see if you can figure out maybe what goes closest with this. I definitely know there is one line missing. There should be 4. So the camera is not picking up one of the lines. But it's doing a pretty good job. Isn't that neat? So this element eats like strawberries and blueberries and maybe, I don't know, water, which is kind of cool. And then to prove to you guys that gases have different ones, let's find another one that's really strong. And just in that amount of time it got very warm. We are going to try this one. This one should be really pretty.
Somebody is guessing hydrogen for that one?
Ooh, somebody's guessing hydrogen.
Oh boy, Griffin, do you have the right answer?
All right, are we ready to try another one?
I'm ready.
It'll take us a little bit of time to see it.
Who's ready to be a little bit patient?
Hopefully this one will be strong enough to check it out. They sort of burn out over time. All right, we gotta turn that light off though.
Are you ready?
We are ready.
Alright, so here's our wide angle. Oh, I see some stuff over here. Let's zoom in on those lines.
Oh, yeah. Ooh, they're not as strong as I'd like them to be. Billy, can you close that door all the way, please? We don't get any extra light.
Lower the light here.
We're working on getting the light a little better for you guys. Because we still have stuff coming in from underneath the doorways, even though it's really dark in here. Alright.
So
Are we able to see some?
We can see lines. You can see it on the screen.
Yay! I can't see the screen anymore. So this looks very different than the other one. Oh, can you see lines? I don't know, it looks black to me.
It's because there's no power to that screen.
Ah, okay. So you guys, Evan's saying that you guys can see lines, which is awesome. That's exactly what we want. And you see more lines than what we saw with the other element. And sometimes having lots of lines is really helpful because it can knock out the one that we're looking for. Think about which one you're looking for. And then let's see if I have another one that we can look at. You guys want to turn on that light.
All right, light coming on.
Who knew you could do science in the hallway? All right, let's see. What have we not done so far? Oh, this one's a fun one. I'm pretty sure if I remember, this one does a really good job. So, whenever you guys are ready, we will plug this in.
Someone said another hydrogen, a neon.
Ooh, for which ones?
So people are saying neon, I guess.
For the last one?
That last one, yeah.
Ooh, that's really close. All right, are we ready?
I'm ready. You ready?
Here we go. Let's plug it in. Oh, there we go.
Whoa.
Oh, hang on.
Is it gonna hold?
There we go. I'll sit here and press the power.
Whoa, that's a lot of lines. Is it coming through to you guys?
Oh yeah, I can see it on theirs this time. Oh, it has a lot of lines. This one's actually a mixture of gases. It is a mixture of gases that we find very, very important.
Anybody guess what that might be?
Yeah, you can try to take a guess. And you can kind of see, if you look at the top where the springs are, you can kind of see, it's really neat. It's like purple actually up there.
Should I look at that thing?
Oh, it's very interesting. There's like this beautiful blue.
So if
They're so pretty.
So if you see the gas over there, and this is the spectrum zoomed out, you can see.
Oh, you can see it.
Off to the side.
Which is neat. And we can make sure that that's what we're looking at by just turning off the power, and it all disappears together. So we know that that gas is creating that sort of rainbowy spectrum that we're seeing. And again, the more complex of an item that we're looking at, the more colors that we would see, which is pretty neat. And I think we can go back to that first one now and compare. I think that might be all the ones that I have with me to look at.
We have an iron gas.
Ooh, for this one?
An argon.
Ooh, argon. We did see argon today. That was the one before the one that we just did. Argon.
Jacob says uranium?
Uranium. Ooh,
That would be very dangerous to have in here.
I don't think the heavy ones actually even can be put into a gas like that. Oh, I have another one.
Ooh, another
one that we haven't done, and then we'll go back to that first one. This one's also a little bit more simple, which is really neat. And this one's really special. We're going to talk about this one in a minute. This one's really special. All right, whenever we are ready, we'll cut the lights. We'll turn it on.
Diffraction grating back on.
This is pretty cool. This is something you guys won't see unless you decide to take physics in college.
All right, lights coming off.
All right, here we go. And we'll turn it on.
Whoa.
Ooh, and that one's like an orangish color when it glows.
Let's zoom in on. Whoa, those lines go far.
And you can see those lines really well.
Whoa.
That's cool. That's a really bright one. I think that's a new tube that I have.
So are we just looking at these
now,
ones, or do I want to see everything to the
No,
left?
so when you see that repeated yellow, that's actually it repeating itself. Just like rainbows, some people have seen multiple rainbows, and the rainbows can repeat themselves. So that's actually what you're seeing in that gradient. So you really want that first like red to blue.
We're going to zoom in on the first red to blue.
Yeah. Which is pretty neat.
Wow. That's a solid one.
Yeah, that one's really good. And you can see as you get close, I mean, there is a few different lines of blues. Two of them are kind of that aqua blue close together. There's a really thick, I think that really thick yellow, and then a very bright red. And you guys could look at your sheets and see what gas might have not too many lines, but has a few lines.
Looks like about 6 to me, but it might have more.
Yeah, it might have some more. Sometimes they get sort of 2 lines that we see might actually blend together, just like in a rainbow that we see a lot of those lines blend together. And scientists in labs have much better ways to actually split these lines apart. They can see them very, very clearly. But this is pretty good for like a little home project.
Mm-hmm.
All right, so I'm going to go back to that first one.
First one we had trouble with.
We'll see if... Well, I'm going to go back to the first simple one. I don't think the first one we had trouble with is going to work. We could try.
Well, we didn't look anywhere near it.
Okay, let's try.
I think we should try it again.
We'll try it again.
So you guys can see from this where I am pointing 2 feet to the left to see these lines, which is why we couldn't see this first one.
All right. Let's see. This is the first one. We'll see if this one will work for us.
All right, lights off.
And here we go. It was sort of weak, though.
Is it going to stay on?
I don't know.
Gotta wiggle it.
It's warming up.
I'm not seeing
It might be, yeah, it might just be too weak. These tubes burn out over time.
I'm zooming in, but I'm not seeing anything where the other lines have been.
Yeah, it's just not as bright. I think that one's dead. But let's look at the first one. Or like, not the first one, this is the first one, but the first one that was successful.
So carbon and sulfur was a guess.
Ooh, I love those guesses. For that last one? What was
for that last one?
I'd have to actually
sulfur, carbon, and we have Kaya saying
Oh.
cool, and then
sulfur and carbon. It
Jack
was not
Sloan
sulfur
said
and carbon.
woo.
Can we get a light real fast so I can
can
read
see.
which one we're looking at? Yeah, this is the one I wanted to see. All right.
So
This was that first one.
first good one. All right, you guys ready to get?
guys
You got
can
your
check
detective
it out.
caps
So make
on?
sure you grab those little sheets you had, and we will turn it
lights
on. Yeah, see how much brighter this one shines than the other one? So you should be able to see the nice pretty lines. There they are.
All right.
Yep, so we're still missing one line in there that we can't separate or we can't check out.
And
I think it might have 2 reds.
I see some yellowish there.
Or maybe a yellow, yeah. It's a little tricky. A little tricky because we can't see all of our lines. Ooh, but we can zoom in on certain ones. I love this.
Should we zoom in on like the blue and see how that blue looks?
How cool is that? So this is basically an electrocuted gas that we are exciting, and it's eating up all of the happy types of foods it likes, and then it's burping it out. And by using that diffraction grating, we can see exactly what it ate. And if you happened to buy one of these diffraction gratings on Amazon, you could take it around in your car without getting out of your car. It could be really fun. If you find neon signs, all the different colors of neon signs are different gases. So we noticed that some of the gases were orange in the tube. This one's pink. We had some that were purple. And you could put your diffraction grating on that and you will see something very similar to what you're seeing now. And that will help you. You could actually determine what gas was inside each one of those tubes. That makes the open red and the circle around it blue and, you know, all of the different colors. That could be a fun little thing to do when we have some neon signs that are going back on. You could ride around in the evening just before bedtime with your little diffraction grating and check it out.
I think it's so cool that light's making all these diffraction lines.
Yeah. So this light that we see that's purple, or pinkish purple, is clearly not just pinkish purple. It's 4 colors of light mixed together to make that color.
And when you put electricity through it, those colors are what's
Yep.
burping out.
Yep, so it's eating all of the energy from the current running through it, and then as it comes down, it burps it out, and it burps out the red, that sort of cyan, the bluish, maybe there's a darker blue purple in there.
Mm-hmm.
I can't remember, which is pretty cool. And we have a few more people thinking that that one was hydrogen, and that one was hydrogen.
Nice job, guys.
So that was hydrogen, which is one of the most dominant items of the sun. And in fact, maybe we should go back to this other one. There's another one that after we did this, and we looked at every single gas that we had on Earth, literally every gas that we knew of on Earth. We checked all of them. We did this project with all of them, and we couldn't actually finish the solar spectrum. There were these lines that were missing, and we searched everywhere to figure out. We tried everything we could to figure out, like, what is this last component of the sun? And it was a big component on the sun. It was a huge component of the sun. And we kept looking, like, what is this? Is it carbon? Is it argon? Is it neon? Everything we could figure out. None of it worked. And then, one day, scientists found a new gas, and it was this one right here.
Where'd they find the gas, do you know?
I don't recall. I think it might have come out of some underground shafts.
I think it was a mine, yeah.
I think it was from some mines. They found something new. It was very exciting. They decided to put it in a tube and to put a whole bunch of electricity across it. And what we got was this, and this was the missing piece. It was what we were struggling to find in that solar spectrum. And its name, you guys might be able to guess, I think some of you guys actually already guessed it. Its name actually plays homage to the sun, because this element was discovered first on the sun and then on Earth, which is kind of amazing if you think about, we discovered an element on the sun before we found it on Earth, which is really cool.
Anybody have a guess for what that
Yeah,
is?
you can guess what you think. And I don't know, is there any guesses about what that element discovered on the sun was?
I can't see, the computer screen's too dark.
You can't see the computer screen, I know. We had to do a whole bunch of modifications for that, which was really fun. That was super cool. This was one of my favorite projects I did while in undergrad. We got to do this as one of our projects, and I thought it was really cool. It's just so beautiful, and it's really fun to bring it to you guys so that you guys can see it. Because otherwise, I don't know, all the really cool science that you get to do at university, we really don't let you guys do. And I don't know why. I mean, that one, obviously, when I do it with kids, there's some safety issues. I'm like, nobody come near me. But other than that, other than the 240 volts that are completely open, I mean, okay, fine. But it's really cool to see.
As we're in the hallway.
Yeah. So, were there any guesses?
There were...
About the one that was discovered on the sun first.
We have how many guesses? We have 1, 2, 3, 4, 5, 6, 7 guesses.
Oh, what are we guessing?
And all 7 guesses were helium.
You guys are all right. Helium was discovered on the sun first, and the sun is very predominantly helium. In fact, 98.9% of our sun is hydrogen and helium. Those are the two most predominant things, and so one of them we were missing for a really long time. So when we finally found it, we named it actually after the Greek god Helios, who is the god of the sun, and it was called helium, which I think is really cool. So we fill our balloons with a gas that we found on the sun first. What? How cool is that?
Kaya keeps on giving the actual names, the letters. So helium is H-E.
Yeah, H-E. Yeah, helium is H-E, hydrogen is H. You got a capitalized one and lowercase the other one. So yeah, we'll pop over into Zoom in just a second. What we'll do there, if you want to, we can work on these guys. So we already know that hydrogen and helium are the top 2, but you guys could use these spectra to see if you can figure out what the next ones are. And if you could even do even further down, you can start figuring out what gases our sun is made of, which is a fun activity. Or we can just watch Tiny Dancer and you guys can tell me all about your amazing projects, because that's sort of the highlight of my day, is hearing from you guys.
So Julie has a question.
Yeah.
Yeah. She always has the tough questions. Would you comment on the reversal between light and print of the spectra?
Light and
So,
print.
we talked about how light is opposite when you're printing it.
Oh, right. Yes. Okay. So, yes, this is tricky. So when we add all different colors of light together, we actually get white light. But when we add all different colors of paint together, we don't get white, we get black. So when you're looking at paint, you're actually looking at subtraction. So you are, if I take green paint, that green paint ate up all of the colors of light except for green. And then if I mix that green paint with red paint, it's eating up all the colors except for red. And of course, the green and the red, they might have some, just like we just saw, it's not quite so simple as green, red, blue. There's all different greens and reds and blues. So as you mix more and more paints together, you're eating more and more of those colors of light, and you're just spitting out fewer and fewer. Because maybe what the green paint spit out, the red paint is happy to gobble up. And maybe what the red and the green spit out, blue paint is happy to gobble up. So over time, as you mix more of those colors, and they're gobbling up colors and spitting out just a few, you end up with no colors being spit out, which is black. But in light, what we have is you actually, instead of having it be absorbed and then reflected off, so like my shirt is absorbing greens, which is why this looks blue. It's absorbing reds, which is why it looks blue. But if I had a light that was actually emitting this color, it wouldn't be absorbing all the other colors. It would just be emitting that one specific color. So then I could have all these sort of flashlights that would be adding together. So instead of taking stuff out, I'm actually adding more things in, and then you get white. So that's sort of the difference between additive and subtractive colors. It's really tricky, actually, though, because they're opposite. They're flipped.
Oh.
Yeah.
Well, that was a very, very great explanation, but she said that wasn't what she meant. She meant how the stripes on the screen ran in opposite directions from the stripes on the printout. And I think that may just be the mirror of the
that might
camera.
just be... Well, also, it might just be... When I originally did these were on transparencies, so it might just be the reflection that I have. And that's just because I decided one side was red and one side was purple. You could flip it however you want. Yeah, that's not... Yeah, you might be right. Did it? I thought red was on the outside, though.
But now you understand both.
But now you understand both, yeah.
Well, on the screen, the blue was on the right and the red was on the left, whereas it's the opposite on your printout.
Oh.
But as long as, like,
Yes, it is.
Yeah.
Sorry, I was like, no, it's not. Yes, it is. I'm looking at through the back. Yeah, that's just like the way that I made it. Because I had to get all these different lines of colors.
She says thank you.
Yeah.
All right, so we have the Zoom classroom open.
Yes.
You guys can click the link that's in your email.
Awesome. Yeah, and we'll have some fun hanging out in there.
Give us a thumbs up.
Yeah, make sure that you follow us on social media. You tell all your friends about the fun that we're having with science. And again, when you join us, you can join for 1 day, you can join for 5 days. Not a big deal. We're just here to support everybody in their day and support everybody in their learning and have fun together and be stress-free. Our goal is to make life easier for everybody else. So if we're stressing you out, just don't come that day. That's totally fine. You can come on any other day. And tomorrow, join us to make this awesome light up little guy who doesn't light up anymore because we stole the battery and the LED. But we're going to make another one tomorrow with happy little planets to sort of wrap up our fun out of this world week in science. And then next week, we're going to do all sorts of engineering challenges. It's going to be a great week for building. It'll be a great week for, I feel like, Connor, Grayson, Elliot, Raiden. Are going to have a lot of the good kids and the Hertz. Like, okay, everybody. I can't call anybody out because it's like everybody is doing such a fantastic job. Like, Callie did awesome. Everybody.
Well, Jordan and Henry are skipping Zoom, so we're going to see them another.
Okay. That's okay. We don't have a ton going on in Zoom today because our class was like much more hands-on and we had to go do all that other stuff.
We're doing a lot of tiny dancing.
So,
maybe you guys
a lot
can
of tiny dancer. A lot of hanging out, asking questions.
Thank you, everybody, for coming.
Thank you, guys.